Welcome back. Now, in the previous lesson, we discussed the definitions of logarithms. We said the logarithm is the mirror image of the index. So if you have x raised to power a is equals to b, then a is the logarithm of b to base x. So how do we use this definition of logarithms to define the laws of logarithms? So if you have 10 raised to power 0, that is simply 1. Any number raised to power 0 is 1. So that implies 0 is the logarithm of 1 to base 10. So any number raised to power 0 is 1. If you have x raised to power 0 is equals to 1, 0 is the logarithm of 1, then to base x. So the logarithm of 1 to any base is always 0. That is Roman number 1 on the rules that apply to logarithms. The second rule that applies to logarithm, the logarithm Roman number 2, a logarithm of a number to the same base is always 1. So if you have 10 raised to power 1, it's just 10. That implies 1 is the logarithm of 10 to base 10, meaning a logarithm of a number to the same base is always 1. 20 raised to power 1 is 20, so that implies 1 is the logarithm of 20 to base 20. So if you have x raised to power 1, that is just x. So it implies 1 is the logarithm of x to base x, Roman number 2. So it means the logarithm of a number to the same base is always 1, a very important law. Roman number 3, the power. So if you have 10 squared is 100, it implies 2 is log 100 to base 10. But 100 can be written as 10 squared. So it means 2 is equals to log 110 squared to base 10. So 2 is supposed to be equals to 2, meaning that squared, the power, can be written as the coefficient. So it is 2 log 10 to base 10. Since log 10 to base 10 is 1, then it implies we have 2 is equals to 2 times 1. So the power inside a log can be expressed as a coefficient, Roman number 3. So if you have log x to power a to base y, that power a will be the coefficient. It will now be a log x to base y. So the power of a number inside the log, the common power, is the coefficient, Roman number 3. So let us jump Roman 4, we move to Roman 5. When you have log x to base y, that is simply log x over log y. The base is the logarithm in the denominator. So if you have x raised to power a is equals to b, then there, by definition, a is the logarithm of b to base x. So if you have x raised to power a is equals to b, if you put logarithm on both sides of the equation, then a becomes the coefficient. So it is a log x to be equals to log b. Divide both sides by log x. So you end up with a to be log b over log x. So Roman 1 is the same as number 1 and number 2 if you compare those equations, meaning if you have log b to base x, that is the same as log b over log x. So the base is the logarithm in the denominator. That is Roman number 5. If you have log x to base y, that is the same as log x over log y. The base is the logarithm in the denominator. Let's move back to Roman number 4, where we have log x to base 10. It's simply log x. So anytime the base is silent, it is always base 10. Because if you press it in the calculator, log 10 is 1. So when the base is silent, it is always base 10. So if you press log 10 in the calculator, you get 1. So if you have log 10 to base 10, according to Roman 5, that is the same as log 10 over log 10, because we've said the base is the logarithm in the denominator. So that log 10 in the denominator, if we put it to be 1, will remain with log 10 over 1, which is just log 10. So log 10 to base 10 is just log 10. So it means when the base is silent, then it is to base 10. So if you are given in Roman number 4 log x to base 10, that is simply log x. Base 10 is always silent, a very important rule. When the base is silent, it is base 10. So log x over log 10 is log x over 1, which is just log x. So log x to base 10 is simply log x. The next rule, Roman number 6, if you have log x to base y, that is simply 1 over log y to base x. So 1 is reciprocal of the other. So log x to base y is just log x over log y. So if you multiply both the numerator and denominator by 1 over log x, it's like taking log x in the numerator back down in the denominator. So we multiply both the numerator and denominator by 1 over log x. Multiply the numerator and denominator by 1 over log x. So in the numerator is 1 over log x times denominator again 1 over log x. It's like multiplying with 1. So in the numerator will remain with 1. In the denominator will remain with the log y over log x. So log y times 1 over log x is log y over log x. So log y over log x in the denominator is simply log y to base x, as we've seen in Roman number 5. So it means when you have log x to base y, that is simply 1 over log y to base x. 1 is reciprocal of the other. Very essential law, rule that applies to logarithms. So can you now try to prove the last two rules when you have log xy? What is that? So when you introduce log inside, it must have either multiplication or division sign. So multiplication changes to addition when you introduce log inside. So if you take log inside xy, so if you have log xy, that will just be log x plus log y. Can the learner prove that? Then the next, if you have log x over y, if you take log inside, if you have division sign, it will change to subtraction. So that is log x minus log y.